Good afternoon. I'd like to take this time to answer 4 questions about the virtual ecosystem. What is the virtual ecosystem? Why are we making the virtual ecosystem? How are we making the virtual ecosystem? And then we can ask you about ways we might want your help in the future. So when we're talking to ecologists, we like to use a quote that says that an ecosystem is more complex than the International Space Station and more connected than the internet. Now, this is probably a pretty hard audience to sell that particular quote to, but I'll try and give it a go. And I'd like you to think about 2 sets of cycles that are going to be going on within our ecosystem. I've picked a rainforest because a lot of our data work comes from Borneo. The first set of cycles are elemental cycles, so the stoichiometry, the ratios of the different elements and the way in which these move through the ecosystem. We have lots of different parts of this ecosystem using these elements. We have the trees taking up carbon from the air. We have them taking up nitrogen and phosphorus from the soil. We have water percolating through the trees, from the river, through the soils. We have the things that we can see here, and there are also the things that you can't see here. You can't see the bacteria in the soils. You can't see all the animals that are scurrying around in their own search to find carbon, nitrogen, and phosphorus. So those are the first sets of cycles. The second set of circles I want to talk about are the circles of life. So we have all of these entities that are interacting from the soil through to the sky, and we have reproduction and demography going on. So we have animals and plants being born, growing, dying, and also along the way, the animals, everything that comes out of the back end of an animal gets deposited into our ecosystem as well. So and those 2 are simple cycles of carbon, nitrogen, phosphorus, other nutrients, and water. So that is what the virtual ecosystem is. It's an attempt to capture all of these processes and functions that are linking together across multiple different domains. So why are we doing this? There's never been a more pressing need to manage natural ecosystems, whether that is to protect or to restore damaged ecosystems, or to work out how to sustainably exploit systems, for instance, for tourism, for agriculture, in order to provide us with the functions and services that we need to maintain life. How are we doing it? Well, Rob Ewers at the top there got a grant from the Nomis Foundation that has allowed him to employ all of these people, a mixture of computational biologists, data scientists, and theoreticians who are trying to tackle this complex coding and parameterization problem. You'll have noticed there are 2 members of the research software engineering team over there on the left. This is one of the supported projects who've been helping us get started and maintain that code culture that is so important to maintaining sustainable and well-supported code. So we're using all the tools that you would hope that we'd be using to maintain a well-maintained and well-reviewed code base. How does the model work? Well, this is the setup. We have an initial configuration that says how the model's supposed to be run. That loads all the data. That sets all the things that are going to be shared across the science modules. We have a spatial grid. We have a vertical structure to represent trees. We have timing, things like that. We have the central data store that the models use to communicate. And then we have the models. These operate in very different ways. So within the soil, we have differential equations to represent the processes of soil bacteria, changing carbon and nitrogen, moving that through the systems. For the abiotic environments, we have the complex variation in vapor pressure deficit and temperature through the canopy. We have hydrology. And then within the plants and the animals, we have demographics. We have cohorts of animals and plants moving through time, and in the animals' case, moving through space. And we've made it in a modular way. So at the moment, that's what we're focusing on, but we can come along and add extra things in when people wanting to exploit the landscape, or there are fires or disasters. How does that change the ecology? So we're making good progress. It's not running completely yet, but we're hoping to get a preliminary thing up soon. We have lots of questions, mostly to do with the treatment of time. So how do you model processes that run at very different timescales? So Vivian, who's sitting over there, has just had a paper accepted in Trends in Ecology and Evolution, which is talking about this and how we might harvest interdisciplinary support to try and solve some of these questions. And at some point, we're going to try and set this loose on the HPC, and it's going to run slower than real time, and we're going to need help in speeding it up. So thank you very much, and I will hand over.